Today we're going to be focusing mostly on differential item functioning in R. Basically, differential item functioning, which I'll be calling DIF or DIF for the rest of the video, occurs when groups have different probabilities of choosing a given item on a scale after controlling for overall scores. So basically, an item has diff when people that have the same latent ability but are from different groups have an unequal probability of giving a response. So this group could be people of different genders, different ethnicities, different age, or education. So yeah, it can be really detrimental to a measurement scale because it biases it. So when we look for diff, we are looking for bias among our questions. And then I'll also be running a 1PL, a one parameter logistic model, or a Roche model, it is also called, and checking for unit dimensionality. And yeah, it'll be fun. So let's go. I already installed these. Gonna pop in the libraries. Psych, LTM, div-r, ERM. I'm not sure if I ended up using anything from ERM, but it's just like a different package that also does Roche models. But it was confusing me with the different code from the last IRT, so I think I ended up sticking mostly with the LTM. But then this diff-r is obviously going to be for the differential item functioning. So like last time, I'm going to use this abortion data set and pretend it is a selection test. I'm going to call it ST. And there's all of the data. Why are they all the same? I guess it was like that last time. Anyways, that's how it looks. Okay. I think there's some variation in there. You just have to keep scrolling around. It looks like they're in order by response pattern, which is fine. So for differential item functioning, I'm going to want another column of a group so that I can look at these group differences, I guess you could call it. So I'm going to randomly generate some more dichotomous data. It's going to be gender, and we'll have 1 is female, 2 is male. And speaking of dichotomous data, this my data is obviously dichotomous, and 1 means that they got the question right, and 0 means they got the question wrong. All right, so this is me generating this data. This set C is just going to make sure that I get the same numbers every time. I wanted a sample of numbers 1 and 2. I wanted 379 of them because that's how many cases I have in this data set I'm using. And then replace equals true, meaning that it'll use the same numbers because otherwise I'd only get a list of 2 because I'm only using 1 and 2. So I'll hit that, and then we can look at it. These are my new male-female set, and then this is just going to add it to my data set. And then I'll look at it again, and now you can see that I have a new column added to my data set that is called gen, short for gender. So now that we have all of that out of the way, I'm just going to go ahead and run this first 1PL model. So I'm not going to get too in depth into this because we talked mostly about it last time, but the difference between what I'm doing now and what I did last time is that this one parameter is the beta parameter, and that is all it looks at, and it's the B parameter, which is item difficulty. So I'm going to run it, and it uses conditional maximum likelihood to estimate the parameters. So then we want to look at it. I've got, so these are my values of difficulty. We can see that these are not the numbers I got earlier, but that's fine. Something must be up with my data. Anyways, it will work. So, and I only ran 1 through 4 because I didn't want to add the gender piece in. It wouldn't work for me when I tried that. So let's look at what we have. These values, so we have item 1 is the most difficult where, because it's the highest value, we have item 3 being the least difficult. We can also see that our Z values are significant. They're all greater than negative or positive 1.65, so with an alpha of 0.05, that's significant. Yeah, so we can plot that to look at it visually. All right, so what you can see here from the item characteristic curves is that this black item 1, as we saw earlier, is the most difficult because it's further to the right. You have to have a greater ability of on this latent variable, on this latent trait. And for this, I think last time we talked about it being an IT selection test, so this will be their ability, their word processing ability. So this question would be the hardest. And this green question 3 is the easiest, which we saw both of those things earlier. So those conclusions are correct. We can look at this a different way by looking at the information, and we get a little bit more information from this. This is an information curve for each item, and it looks like we get about the same information for all of them. Yeah, they're all about equally as good at providing information about the latent trait. So now we'll plot the entire test. Whoops. Yeah, so that's the whole test. And it just shows that this test is giving us the most information for people that are in the middle of the distribution on this word processing ability, so it's not going to help differentiate between people in this lower area, people in this higher area, but it will tell us who's in the middle and who's in these outer ends, but it won't differentiate between these outer ends because there's not any information out here. Oof. So now we're going to test for unidimensionality. Going to run this here. It's just saying that I want to test the unidimensionality of my Roche model using this data set and only the first 4 columns, which are my test items. And we'll run the test. And it should, there it is. So it gives you this matrix of these correlations. But what we want to look at is if the second eigenvalue of the observed data, which is my data, is substantially larger than the second eigenvalue of the data under the assumed IRT model. It does this by running a Monte Carlo simulation, and by default it does 100 because I didn't specify, but I thought 100 would be okay. And after running that, so this was what it was in my data, the second eigenvalue. This is what it was in the Monte Carlo sample. And yeah, they ran 100. P-value is 0.0594, so that is very sad, but it is not significant. So really, this data would probably fare better in a different IRT model. But for the sake of needing to do the differential item functioning, we will keep going. I also plotted this test with the legend because it is kind of nice to look at. You can see those eigenvalues. The black line is my data, the red is the Monte Carlo data, and yeah, it's basically just showing this, but in plot form. So when doing differential item functioning and picking a detection method, you're going to want to pay attention to the 4 dimensions, which are the number of focal groups, the methodological approach, which is either IRT based or non-IRT based, the type of DIF effect, which is either uniform or non-uniform, and whether or not item purification is used. So in my example, I have 1 focal group, which is going to be women from the group gender. And my methodological approach, I do want to use an IRT approach because, and it's going to be a 1PL like I ran earlier because that's the model that we're looking at. And for 1PL, you can only detect uniform diff, whereas 2PL and 3PL are suitable for identifying both uniform and non-uniform. So that means I will be wanting to use the, I want to be looking at uniform diff effects, which is when the difference between the transform probabilities is independent of the common ability value. That's when the DIF is uniform. Lastly, I'm going to purify my data that is a way to prevent getting any false positives as DIF items. And it follows a stepwise process, but all I'll have to do is just put purify true here. So with all that being said, I'm using my data selection test. I'm using gender as a group, focal name women, model 1PL, like the Roche model we used earlier, and then we're gonna make sure it goes through that purification process. Oh, and like I mentioned earlier, since I am doing IRT and I'm using an IRT method and I can only look at uniform, I can use LRT method or approach, Lord approach, or the Raju approach. And I ended up using the Lord approach because it seems to be a little bit more popular in the DIF framework, and it also allowed me to type in this model 1PL section here. The Raju model also let me do that, but the LRT would not for some reason. So I'm going to go ahead and run it. We can look at it. What we see here is that my item number 1 had a p-value of under 0.05 under the significance level and above the statistic. The chi-square statistic was a lot bigger than the detection threshold. So we can see that with this little asterisk that we've got less than 0.05. So, and then it tells you straight up right here, items detected as diff items, item 1. And then it'll tell you about the effect size. So it had a moderate effect, and then the other 3 that were fine had a negligible effect. And then we see gender down here that its effect size was C. So I guess that shows where the gender group, like with all these items aggregated, where they kind of land, and we can see it on this plot. We see my item number 1 above the threshold, this 3.8415 threshold, and all of these are below. There are different ways, a few other different methods that we could look at to detect diff. I chose Lords, but I could have also used LRT or Rajus as for LRT and uniform. Like I said, LRT wasn't working for me because it wouldn't let me put the 1PL model, so it also wouldn't run in here with 1PL. So I ran it this way, and I wanted to use the MH function for mantle Hansel because that's a popular test, and to be honest, I was using it earlier and then I talked myself out of it, so I just want to see what kind of results I get with it and how it compares to the Lord and Raju methods. So I'm just going to go ahead and run it, which I actually already did. We have comparison of diff detection using the 3 methods. We have Lord's chi-square test, Raju's area, and the mantle Hansel. It's going to give us some parameters like our significance level, what statistic it's using, if it's correcting, if it's purifying, what type of model, 1PL. So it's showing us it did 1 iteration of each. And what it found was the Lord and the Raju ones agreed, which makes sense because they come from the same grouping of methods, and this MH is called diff for each of them, which kind of makes sense because it was saying because it's not ideal for IRT and uniform or 1PL RT methods. So I think that, yes, that's my best understanding. And then item 1 has diff all across. So actually, it is looking pretty clear that item 1 has diff, which would mean that item 1 is harder for women based solely off of their gender. So this can be really important for IO because using the example that this was a selection test, and for some reason an item on the selection test, item 1 in this example, was harder for women solely because they are a woman, and easier for men because women are a protected class. This could lead to adverse impact and potentially some legal drama. So yeah, that's all I've got for today. See you later.